Hey, it's Jacob. Welcome to this new video. Today I'll talk about when programming will be automated. How long is that gonna take for programming to become worthless? So by the end of this video, you'll have a clear idea of whether or not programming is still worth learning or if it'll be automated in a few years. More specifically, I'll talk about the two main reasons why people say that, the assumptions behind it, and the reality of what automation is. Basically, how it actually works in practice. So the first thing that comes to mind is that there are more and more tools about automation, and a lot of those tools concern programming. So you might ask yourself, if there are all those tools that are growing and that are becoming more and more powerful, why should I learn programming at all? It might make you feel stuck and demotivated because even if you learn programming, then in a few years it will be completely useless if everything is automated. And maybe you know that neural networks don't need programmers, they just need tons and tons of examples. And based on those labeled data, then they learn, and then they become superhuman. They don't need the intervention of a programmer. So again, why should you learn programming? And perhaps you feel like programming is just a waste of time. And maybe you think, well, if I learn it and if I invest all this time and energy and then it becomes obsolete, then it would have been just a waste of time again. So the problem is, whatever you choose to do, you lose, because if you choose to not do anything, then nothing's going to happen. But if you choose to learn programming, then maybe it'll become obsolete and you would have wasted your time. So it's an extremely disempowering situation. Now, most of the time, here is what people say in this situation. It's gonna be fine. Now, most people might not utter those words exactly, but that's substantially what they are saying. They would say things like, don't worry about it. It's gonna be fine. Things are gonna work out. And I mean, it's like, that's great, but that's not good enough for me. Why? Because usually what happens when there is an innovation and people don't worry about it? I mean, when Uber started their thing, taxi drivers didn't worry about it either. And as you know, unfortunately for them, not worrying about it was not a good strategy. Or you might have heard, well, we're not there yet. Well, how do you know for sure? I mean, look at self-driving cars, like they're pretty advanced. There are really advanced systems today that are being automated. So how do you know for sure? And also, although we might not be there yet, how do you know we are not going to be there soon? How reliable is your prediction about the future? Now, if you felt confused about the fact that these explanations don't make sense, I felt confused also because those things actually don't make sense. Now, the truth is, the unknown is uncomfortable. That's the reason why people don't make sense about those things. Being delusional is usually the most comfortable path, even when we know full well that things are not going to be fine. So what you really need right now is a sober examination of where we are at without falling at the extreme ends. Now let's go back for a second and look at why people say that programming will be automated. In March 2016, AlphaGo defeated arguably one of the best Go players of all time, 4-1. If you don't know what Go is, it's a Chinese game where you put stones on the board. Let's say that it is similar to chess in the sense that you can kill your opponent's stones. You might think, what does it matter? Kasparov was defeated at chess by a computer years and years ago. One, because Go is far more computationally costly than chess. Just to give you some idea of the number of games possible at Go, far exceeds the number of atoms in the universe. That's the first main difference. The second main difference is the algorithm used for Go is very different from the classical algorithms because there is no actual code in it. Now, of course, this is a massive simplification, but for the sake of argument, let's say that there was no actual code in it. So the main point is that's an algorithm that learns through examples. So at the time, we would give examples of the game, and the algorithm would learn to play the game that way. And the algorithm that learns is called a neural network. Neural networks are the algorithms used today in self-driving cars so they can learn how to drive. Alright, so what? Well, there are two separate arguments. One, if we didn't need code for Go, we don't need code for the rest. Two, if neural networks can learn to play Go at a superhuman level, then they can learn to code at a superhuman level. And those arguments are true to some extent, but there are issues with them. So let me explain very briefly what those two arguments are about. The first argument again is they didn't use code to play Go. They used examples to train the AI or the neural network. Well, it's not entirely true because they needed actual lines of code, but let's say that it is for the sake of the argument. So basically they showed tons and tons of game and said who won the game, and the AI figured out how to play the game this way. So that means, for example, if we need to create a software that knows how to drive to put in a self-driving car, all we need is examples of how we drive. So that means we don't need programmers. All we need is people that know how to drive. And by the way, programmers don't necessarily know how to drive. So we definitely don't need programmers. And now, second argument is it's difficult to program, but it's also difficult to be good at Go. So if a program learned how to be good at Go, it can figure out how to program. We can use that same technology that learned to become good at Go to become good at programming. We do that once and for all, and we have an AI programmer. Then we could ask the AI to create a software that generates an Excel report, for example. The AI would just write the code for you. And again, we wouldn't need a programmer anymore. We would just ask the AI to do the programming for us. All right, now that we talked about the arguments, let me talk about the assumptions behind those. First assumption, requirements are unambiguous. This means software requirements can be interpreted in different ways. So let's say that we have an AI programmer. We have to ask the programmer what we want to do so that the programmer will write the code for it. That's how it works in the real world. And the problem is there is room for interpretation in the requirements. So how do programmers solve that problem? Well, they solve it by talking to people. That's how we can have requirements that can be interpreted and still have a software that works and does what we want it to do. So now one might say, well, what about an AI that writes the requirements so that then there is no room for interpretation? And sure, that would work, but what would it be based on? Remember, requirements are literally what we want to do. I mean, for example, how do you tell an AI to create an Excel report generator? What do you say to the AI exactly? And maybe you have an answer for it, and it's fine. It's not something that can't be solved. But whatever your answer is, that would be what the programming part would consist of. And maybe you would have invented a new way of programming. The point is, this would still be programming. It would just be a different way of programming. Second assumption, deployment is easy. So this is for people who say, well, once the feedback loop of the training is set up, all we need is tons of examples. And this might be true, but in the real world, this is equally as hard as writing the code. Plus, there is another problem with this. What if the problem you want to solve is new and you don't have any example? If your boss is asking you to write an Excel report for the first time, well, you don't have the examples required to train your neural network with. So that's the problem we don't have an answer to. We can't train a neural network without data. Overall, for me, asking the question, is learning programming a waste of time, is equivalent to asking the question, is learning math a waste of time? I mean, when you think about it, you don't need to learn math because we have calculators now. It's like, yes, calculators help, and mental arithmetic is 100% useless right now. But are math useless? Well, not really, because math involves more than just mental arithmetic. And in a lot of ways, calculators might have been more helpful for math than neural networks are helpful for automating programming. Obviously, I'm talking about right now in 2022, and the reasons for this are calculators are cheap and neural networks are extremely costly. Why? One, you need to find the data. Sometimes you just can't do that, as we talked about. Two, you need to label them, which means you need to explain what is happening. For example, if you take self-driving cars, you need to tell them, this is what we do in this situation. Just the video of what's happening is not enough. You need to tell them, here in this situation, I'm going to turn right or turn left. And this can be extremely time-consuming or extremely expensive. And three, provided they exist, you need tons and tons of examples. If you don't have enough volume, don't think your neural net is going to be any good. So if we take the current state of where neural networks are at, they are not cost effective for most problems. So to come back to the original question, when will programming be automated? My answer is I have no idea, but given how powerful such an AI would be, when the time will come, most of the other jobs would probably also be automated. So if we say that we shouldn't learn programming based on this argument, then why learn anything at all? Now, if you do want to learn programming, I would recommend Python to get started, but I know when you're a very beginner, it's not easy, and also you might waste tons of time finding useful content. That's the reason why I created a free online course to help you avoid wasting your time and energy. You can click on the link in the description to get it. Now let me know in the comments if you don't agree with what I said in this video. I'd love to read them. Have a great rest of your day and see you in the next video.